In this video, I'm going to break down the most misdiagnosed piece of equipment on your cook line in a commercial kitchen application. That's right, the Millivolt gas fryer. These are so easy to work on, but so overlooked by so many techs. I'm going to give you 5 tips and tricks that are going to make you a successful repair person on these fryers. All right, let's talk about one of the misdiagnosed pieces of equipment in a commercial kitchen. That is the basic Millivolt fryer. We're going to go through and I'm going to give you 5 tips on how to successfully diagnose this fryer. So follow these tips and you're sure to get it. Let's go. First off, gas pressure. You need to check gas pressure in 2 places. Manifold, your data tag should tell you what it should be. This one says 4.0. And then incoming, I'll insert a picture of where this one is on this valve. It's actually on the side back here in the back. Kind of pain in the butt to get to, I know, but you need that information. So right now, pilot lit only. Static pressure is 6.78. Let's turn this main burner on. Main burner is on. We dropped to 5.76. We got 4.12 inches of water column. So we know our gas pressure is good. So that's the first thing you want to check, is incoming gas pressure, static dynamic. Also, if you've got a lot of other pieces of equipment on this line, you're going to need to fire everything up. We want to make sure we don't have a volume issue. We know about pressure, we got pressure, but volume you can't see. So how you check for volume is you want to go through and turn everything on that uses gas, and then see what your volume is, your gas pressure is. If your gas pressure drops too low, you know you have a volume issue. You see this a lot of times in older restaurants, where they just keep adding more and more equipment on and still the same gas supply. You'll look back there, you'll see an inch or inch and a half gas main. You'll just see T's everywhere feeding equipment, and equipment starves. So that's a big no-no. So gas pressure and gas volume are your #1 things to check. Also, gas pressure, look on the back of your fryer. You may have a pressure regulator, and here's mine. Pull that cap off. And there's a screw in there. You can adjust the gas pressure. In is more pressure, out is less pressure. All right, you know your gas pressure is good. So let's see what's going on with the millivolts in the system. For that, you're going to need a DC meter. This one's auto ranging, so I put it on DC. And you want to hook it up to your thermopile thermocouple. This one has a thermopile, so red to red, black to white. When you're testing this, you got to test it several different ways. Some manufacturers actually want all those readings. So we have it unhooked. We're going to light this pilot. So this is going to be testing millivolts with no load. This is only the thermopile in the circuit. So we're just going to light this pilot and see how it generates. Now I have to hold this button in because it's unhooked from the system. So it's not going to hold itself open. So, just going to hold it in for a while. We're going to see what kind of millivolts this thing generates.
A few moments later.
So we're up to 650. I got it on my phone too. So this thermopile is working great. It's still climbing. So we know we have good output out of it. Let go of that. Now let's hook this thermopile back up. If you don't know where it goes, look at your door. Most of your doors have a diagram on there to show where it goes. So tied back in. Let's go ahead and hook this back up. I like to use these alligator clips because it holds themselves. So I'm just on that red terminal. I'm going to go on the white here. So we're hooked back up. Now the next thing we're going to check on millivolts is pilot load. So it's only going to be the pilot valve. So push this in, let it pilot again, generate millivolts. So probably hold itself in now. Let's see how high millivolts we get with just the pilot on. So once again, our pilot's staying in, millivolts are good. We know that coil is not the problem. So I mean, this thing's rocking and rolling, right? Turn it on. Let's see where it drops down. With the main valve on is the 3rd test. We dropped down to 250. We're still climbing a little bit. So generally, unloaded, I see 700, 750. Pilot only, I like to see 400 to 550. 550 is on a really high end, but 400 to 500 is good. And then on a full load, I like to see above 250. So if you have all three of those, your thermopile is not the issue. So 750 unloaded, 400 to 500 pilot only, and then 250 and up, everything on. Next thing we're going to talk about is pilot size. Your pilot should not sound like a blowtorch. If that's the case, you got some issues going on, you may want to check your gas pressure. So if your gas pressure is too high, you're going to have a really big pilot. The reason that is, your pilot is unregulated by the valve. It's on the side before the regulator, internal on the gas valve. So it's just getting full pressure. So if you got 10 inches of water column coming to this, you got 10 inches of water column going to your pilot. So you may have to adjust it down. To adjust it, there's a screw down here. You pull the screw out. It's got a needle valve in there. You can work it in and out, and then actually decrease and increase your pilot size. So if you're trying to get one to run a little hotter, gas pressure is not really out of line, but pilot's just a little too hot. You're taking out thermopiles. You can turn that valve in and close that needle valve, and then actually shrink your pilot size a little bit. Don't go too low because you don't want to have nuisance tripping issues, but keep that in mind. So this one right now, pretty healthy. We got 7 inches of water column. See if I can back it down a little bit by the regulator back here. I can already hear it change the sound. Let's see what gas pressure we're at. I'm at 4.82. Our millivolts are falling actually, so we're going to be closer to 500. Get gas down to 4 inches water column, and my output is down to 524 and falling. So let's check this out. And that shows you the size of the pilot matters. So here's an up close view of that pilot. See, it's big and robust. Currently we're running at 565.2 millivolts. So right now we're running 6.9 inches of water column. I'm also going to simulate what happens with the gas pressure and how it can affect the pilot. You can already hear an audible change. So now I'm at 2.98 inches of water column, and my millivolts is dropping out. So that just shows you that gas pressure can affect your pilot size because that gas is unregulated on that pilot. So whatever gas pressure you feed this fryer with is whatever that pilot's getting. So that comes into play when you got a 2-pound system. Another thing is if your gas pressure is good, but you still got a weak small pilot, those orifices like to clog. This is a fryer. There's grease in the air, there's dirt in the air, flour, breading in the air. This isn't a clean environment, so those will get clogged. So if you do have good gas pressure and you still got a weak pilot, you try to adjust the needle valve, it didn't help, you're gonna have to pull that pilot out. Okay, so you pull the pilot out, so you clean that orifice. That's that orifice down in there. Generally, you can take a screwdriver or something and pick at that hole. Blow out some nitrogen or CO2 or whatever you got. And yeah, that's how you clean that orifice. Yeah, I can't get it out. I don't want to tear it up. You can see it down in there. A little bit hole. Just make sure it's clean. If you got a orifice drill bit, you can run down through there. Do not open it up. Just clean it out. Generally, you can just pick at it. Something that's clean though. Put it back in there. Don't tear it out. Tear it up. Sorry. Now, be careful because that will cross thread pretty easy. I like to go as far as I can by hand, just to get most of it threaded on. So you can use a wrench or whatever. Just snug her up. Now, if you have to change your thermopile, you can just unscrew this, screw it out like I did earlier, and it just held in by this little retention nut here. Make sure that nut is on before you attach it or you won't get it on. So nut goes up the wire, pretty easy. Let me fish this back through here, get it back on there. Same thing, run it in as far as you can by hand. Let's get a little snug. So a couple other things to look out for. It's candling. Candling is what it says. You'll actually see like a little candle flame out these, and what happens is this gas valve shuts off slowly, or not fully, and the flame will actually come down through the burner and you'll have a little candling here. What that'll do is that'll set up your burners, cause some burn issues, but really it's a sign that your gas valve has something stuck in it and needs to be replaced. If you're going to do that, make sure you check your incoming pressure. Could just be too high pressure holding it open, or damage the valve. So that's just a couple things I'd look into. These burners, if you do got to clean them, pull them out, take this little set screw out here, 2 half-inch bolts, pull them out, they lift up, come right out. You do have orifices in here. These orifices can get dirty. You can clean them out with just about anything. A pretty good sized orifice, you can actually unscrew it or pull it out, not a big deal. All right, so let's say you can manually light your pilot, but when you let go of the button, it shuts off. Several different things can cause this. One, a high limit that is open, or 2, you may have a ground in the system or a short to ground. So let me get my pliers here and demonstrate this. So if you have any shorts to ground, it's going to kick it out. So I'm going to go from red to ground here. Pilot dropped out, shorted out, took voltage away from the magnet that's energizing that pilot valve, and to ground. Electricity always takes this path of least resistance like everything else, and when you ground it out, no electricity is going through that coil anymore, and it's taking out the pilot. So you want to make sure your system's not grounded anywhere on the positive side. So let's relight this. Pilot's good. If you got to shorten your ground, drops out. Now let's say a high limit issue. If I look at my wiring diagram over here, yeah, high limit is red. This red wire goes off my high limit. comes back through my blue, and it goes back through my thermostat, and it comes back to my ground. So if I take this blue wire off, it'll simulate my high limit opening up. High limit is now open, not completing my path of power back to my valve. Valve drops out because it thinks there's a problem, kills the heating circuit, therefore if it doesn't run away or whatever is causing that high limit to trip. If you want to test if your high limit is good or bad, you put your meter on the leads, going from red to this blue. And you can test resistance through there, continuity. We have 0.02 ohms or continuity. So that means the high limit is good. Now, your wiring may be different based on the model, the manufacturer of your fryer, but that's just how I do it. So you know high limit's good. Relight this pilot. So let's say your thermostat, you think your thermostat is bad. How you're going to test that is you can turn it on. If it doesn't click, okay, it's not clicking, you'll see what's going on with it. You can also check at your gas valve. So if you look at your circuit, red goes over, goes into your high limit, comes out your high limit on blue, that comes out and goes to there. It also comes out and goes through your thermostat, comes out of your thermostat on brown. So you should have continuity between brown at your valve and red going to your high limit circuit. So let's kill this. So we got that shut off. So let's pull this brown wire off. Again, use my alligator clamps. Red to brown. Our thermostat is in the off position. Turn it on. Circuit's complete. Turn it off. Circuit's not complete. So you know that your high limit circuit's good because it's going from your red through your high limit, out of your high limit on blue, blue into here, blue out of your high limit to blue here. Coming out here, goes to brown. Turn it on. You have a signal back to your brown, to your gas valve. So your gas valve should come on. Let's hook this back up. Pilot's lit, turn your valve to on. Turn your thermostat on. Give it a second. That generated enough millivolts to work it. And we are rocking and rolling. We're heating. Alright, so we know our gas pressure of the unit was good. It was 7 inches. So let's say we have a weak burner flame. You can adjust your burner pressure, burner manifold pressure, by taking out this screw. It's the same as any other regulator. You screw it in, you're going to get higher pressure. You back it out, so you get lower pressure. Currently we're at 4. I can back this out. Bring it down to 2.4 and back up to 4. So that's how you get your set your manifold pressure for your gas pressure. Pretty easy to do. Just make sure you put the cap back on. Another thing to look out for is these vents. These vents have an opening down here. They can get clogged. So you may have to pull that out, blow it out, wash it out somehow. Just make sure it's not clogged in there. Because if that vent gets clogged, it'll affect that regulator. So yeah, that's it. Thermostat high limit. Capillary is coming up the back. And go into the bottom of the fry pot right there. But other than that, I mean, they're pretty simple. You follow all those steps, It really works you to what's wrong and what's going on with the fryer. 99% of the time, it's a gas pressure issue. Too high gas pressure, too low gas pressure, low gas volume. So that's why it's important to start off by checking your gas pressure static dynamic, manifold, and then run through the checks on your thermocouple thermopile system. If those all check good, then you do have a problem somewhere in the fryer and you need to figure it out. So I hope you guys enjoyed that. Thanks.